expressions. Just like we did with multiplying, I'm going to ask you to look at several increasingly complicated examples and come up with your own algorithm. Let's start fairly straightforward with the problem of x to the fifth divided by x to the third. Much like with multiplying, when you're new to this, I strongly recommend expanding things out. We recall that x to the fifth means x times x times x times x times x, and x to the third is the same thing, but just 3 times. So that's it fully expanded. What I want you to consider is remember a fact from probably 7th grade. Any number divided by itself is 1. So every time you have an x over an x, it reduces to 1. You can reduce 3 pairs of x's this way and come up with 1 every time. Now you're left with a very simple problem of x times 1 times 1 times 1 times x in the numerator and just 1 in the denominator. So that whole thing just simplifies to x squared. Let's try something that's a little bit trickier, shall we? Let's say 3x squared y cubed divided by 6xy squared. Now if it helps you, you can go in and write a little 1 that would be otherwise invisible over the 6x, over the x that's with the 6 in the denominator. I would encourage you once again to expand everything out. 3x, x, y, 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 divided by 6x, y, y. Let's take a look at our coefficients. 3/6 pretty easily reduces to 1/2. So let's go ahead and write that in as part of our answer. Now let's go ahead and reduce where we can. We've got an x here and an x here that both reduce to 1. We've got a y and a y, another y and another y. Those are all going to reduce just to 1. And all we're left with is an x and a y in the numerator. So 1xy over 2 is our answer. Let's try another example. These are not really any different. The rules that you're applying are the same. And remember, as I go, I want you to be thinking of what an algorithm might be that you can use. Do you see a shortcut like you did for multiplication? So our problem is negative 15 a squared b to the 7th over 25 a to the 5th b to the 3rd. We can go ahead and expand that out. You're going to get negative 15 in your numerator, 2 a's, and at this point, 7 b's, 1, 2, 3, 4, 5, 6, 7, over 25, and then 5 a's, 1, 2, 3, 4, 5, and 3 b's that are all getting multiplied. Now go ahead and reduce where you can. A over A, you'll notice I'm crossing them off in pairs. That'll both reduce to 1. I've got a B and a B, B and a B, B and a B, and these all reduce to 1. And what I'm left with is B to the 4th on top, A to the 3rd on the bottom, and I still have my coefficients to deal with though. So I have B to the 4th power, A to the 3rd, and reducing negative 15 over 25, I can divide those both by 5, and I'll be left with negative 3 over 5. And there's your answer. Have you thought of an algorithm yet? Is there a way that you could have gotten these exponents by looking at these up here, by starting with the exponents that you had? Think about that for a minute. And let's try one more example. This one's a little tricky, but I'm looking to see if you can kind of read between the lines here. 3a squared b to the 5th over 3a squared b to the 3rd. Those of you who are really scrappy, and that's a good thing, are going to notice that these expressions are identical. So your answer can just be 3a squared b, and if I expanded them all out, to the 2nd power. Again, ask yourself what your algorithm is. I've got two last examples that I would like you to try. First one is this, -4 x squared y squared z to the 5th power over 12, excuse me, x to the 5th, y, z to the 5th. And example 2, I'll call that 1 and 2. This one's a little tricky. Let's see if you can put things together from what you learned last week. 3x squared y squared to the 3rd over 9 x to the 4th y to the 5th. For this second one, I'm going to ask you to remember PEMDAS. That's going to come in handy as you solve this one. Go ahead and try those two. Then think about your algorithm for division. Write it below, and does it make sense with the algorithm for multiplication? Why or why not? Thanks. We'll do a few more examples like this in school when I see you. Have a nice night. Bye-bye.